Find the general solution of this one. So now, apparently, this looks of the form a polynomial type times an exponential. But remember, for a polynomial, the powers have to be all positive integers or just constants. So this time we have t power -8, and that's not a polynomial term. So anytime you have a negative power on a variable or a fractional power on a variable, then that's not a polynomial. So this is not one of the forms that we have for the method of undetermined coefficients. Therefore, we will have to use the variation of parameters here. So we start by solving the homogeneous equation, which is y double prime minus 10y prime plus 25y is equal to 0. Auxiliary equation is r square minus 10r plus 25 is equal to 0. Now this one factor, this is a complete square of r minus 5. So this is r minus 5 whole square. So we have a repeated root, r is equal to 5. Repeated root. Let's change the font back. We have a repeated root. So in this case, let's just open up. So which one was it? Section 4.4. Okay, so trying to find the template for the repeated root. Maybe it was 4.3. So let's see. And maybe 4.2. Okay, so in case of repeated roots, we have real and equal roots. This is the general form. So the homogeneous solution would be, so this is the homogeneous solution. So we call it YH. So YH is equal to C1 plus C2T to the RT, and R is 5, so it would be C1 plus C2T to the 5T. And then we go to method of variation of parameters to find the particular solution. So let's just go to that section. 4.6. Okay. So remember, the method is you find a particular solution, you find two independent solutions, which are the ones that are appearing in the homogeneous thing. And then we write yp equals to this form. Copy. So now in this case, remember I told you when we did problem number 1 that whatever comes with the C1 and the C2 are the two independent solutions that we use. So we can say the two independent solutions are Solutions of the homogeneous equation are, so y1 is equal to, so you see, if you expand this out, you get c1 e to the 5t. In fact, let's even write it like that. So you get c1 e to the 5t c1 c1 e to the 5t plus c2t e to the 5t c2t e to the 5t. Okay, so y1 will be whatever comes with c1. So y1 is e to the 5t. And y2 is whatever comes with the c2. So with the c2, we have t e to the 5t. Okay, so once we have that, then we write the particular solution according to the method of variation of parameters. So the yp will be this thing, v1 y1 plus v2 y2. By method of variation of parameters, yp will be v1 y1 plus v2 y2. And now let's substitute the values. Y1 is e to the 5t. And y2 is t e to the 5t. Okay. So we got this yp. And now let's go back and see what the next step was. The next step was that we find v1 and v2 by solving these two systems. So next, we solve the systems. Okay. So y1 will be e to the 5t. Or let's just keep this and now substitute the values. So y1 is e to the 5t, so that you know where the things are coming from. Copy. Okay, and y2 is t e to the 5t. Okay, and then y1 prime would be the derivative of e to the 5t, which will be 5e 5t. So y1 prime will be 5e 5t. And y2 prime would be the derivative of t e to the 5t. So here we use the product rule. So my product rule this is the space for this derivative. Okay, so t e 5t. So the derivative of t is 1. So we'll have 1 e to the 5t plus, and then we keep the t, and the derivative of e to the 5t will be 5e 5t. So I write the 5 here and e to the 5t. Okay, so these are the two, and f over a. F is the right-hand side. Right-hand side is this one. And a is 1. A is the coefficient of y double prime. So y double prime coefficient is 1 here. Okay. So let's see, what would be the quickest way of doing it? So I spot a very nice way. If we subtract 2 from 1, so let's call them 1 and 2. So 3. So this is 1 and this is 2. So if we subtract 2 from 1, the 5e5t v1 prime, okay, so no, we'll need to multiply 1 with 5 so that this term and this v1 prime term and the v1 prime term become the same, and then we subtract them and the v1 prime will go away and only v2 prime will be left. So multiply 1 with 5 by 5 and subtract from 2. Subtract from 2. So when we multiply this by 5, okay, let's just write 2 first. So 2 is, so this is 2. And when you multiply this one with 5, you will get 5 here, and you will get 5 here, and 0 times 5 is 0. And then when you subtract it from 2, you get negative. And this becomes negative. And so now you can, when you just add this to 2, we get, okay, so 5e 5t v1 prime minus 5e 5t v1 prime, that's gone. So with the v2 prime, you will have this part minus this part. No, minus this part. And then on the right side, it's t to the negative 8 e to the 5t plus 0. So that's just t to the negative 8 e 5t. Okay. So now let's see, this simplifies. These two terms also go away, and you just have v2 prime e to the 5t. v2 prime e to the 5t equal equals t to the negative 8 e to the 5t. And e to the 5t's will also cancel out when you divide. And so you just get v2 prime is equal to t to the negative 8. Okay, and now v2 prime is dv2 over dt. So dv2 over dt is t to the negative 8. Or you can just think of it. Okay, let's just do the step. So v2 prime is just dv2 over dt. Is equal to t to the negative 8. And now we do it by separation of variables. So dv2 is on the left. And on the right side, you have t to the negative 8 times dt. And now we integrate both sides. Remember, this is method of separation of variables. So we get v2 is equal to t to the negative 7 over negative 7. T to the negative 7 over negative 7. Okay, so we got v2, and now remember in this method of variation of parameters, we don't write the constants after integrating. And then v1 will be obtained by substituting it. We should do it in the easier one. So this is the easier one. So substituting this in 1, we get substituting this in 1, we get, okay, so 1 was this. Okay, e5t v1 prime plus te5t v2 prime. So v2 prime would be, or let's just, okay, the derivative of this. So what's the derivative of this? So the derivative of this is actually this t to the negative 8. T to the negative 8. Because remember, we can just go at this step because we have to substitute v2 prime. So v2 prime was t to the negative 8, and this was a v2 prime over here. So let's see if we are in a position to get v1 prime out of this equation. So we will first keep this one on the left because that has the unknown in it. So you keep this one on the left and you take the other term on the right, so it becomes a negative. And then you divide out by e to the 5t, so you just get v1 prime on the left. Equals, and now this one simplifies. T times t to the negative 8 becomes t to the negative 7. Right? And then we integrate this to get to v1 prime, to get v1. So, or sometimes when it's that simple, we don't even have to write this step. We just can say integrating both sides. Both sides. So the integral of v1 prime is v1. v1. And the integral of negative t negative 7 would be negative. So this would be t power negative 6 over negative 6 when you use the power rule. Negative 6 over negative 6. And so this becomes just positive. Negatives go away. T to the negative. So now we have both v1 and v2, and therefore yp would now be, where is yp? So this was the form of yp. So yp was this one, and that would equal substitute. v1 is t to the negative 6 over negative 6. And v2 was t to the negative 7 over negative 7. Okay. We have yp, and therefore we can now write the general solution. General solution is yh plus yp. So let's write the template for that. The general solution is yh plus yp. And substituting yh was the homogeneous solution, which was here. And yp was this one. Okay, so let's enter C1E5t plus C2t e to the 5t. C1E5t plus C2t e to the 5t. So let's write A and B. AE5t plus bt e to the 5t plus t to the negative 6 over 6 e to the 5t, t to the negative 6 over 6 e to the 5t, t t power negative 6 over 6 e to the 5t. I think the next term was minus t power negative 7 over 7 e to the 5t. Okay. AE5t plus BTE5t. Let's check. AE5t, BTE5t, t to the negative 6 over 6 e to the 5t minus t to the negative 7 over 7. Oh, there was a t here, TE5t. Okay, so let's do that. There's a t here. Now that t can be combined with the t to the negative 7, but I think it should take it even in this form. Yeah.